Welcome class to our next video in our equations unit, and today's topic is combining like terms, and the learning target sounds about the same. It says I can solve equations by combining like terms, and this is something you probably have done in the past too, but combining like terms in the simplest form would be like if you were to take 2x and add it to 3x, you would get 5x. So that's what combining like terms is in its most basic form. Get rid of all that. And we're going to start with an equation that you can't solve unless, oh look, restart required. Nope, I'm not going to do it. Unless you combine like terms, it's the way to do it. So let's take a look at this one. We have 2x plus 6 plus 7x equals 33. So we notice that 2x and 7x are both on the exact same side of this equation. So by side I mean on the left side of the equal sign. So what we do is we are allowed to combine the 2x and the 3x together. So sometimes I underline it like I just showed, sometimes I circle those, and when you add 2x and 7x you get 9x. And that's kind of how I show my work, by showing those two things right there. Plus 6 equals 33, and if you draw that line through, you just keep the equation, the equal sign on that line. And this, now we're back to a two-step equation. So a lot of these, the new things I'm showing you, which may not even feel that new to you, just bring us down to a two-step equation all the time. So now we subtract 6 on both sides. We get 9x equals 27. Divide by 9. That leaves you with x equals 3. Now we still are doing the check. Every time we add a new wrinkle to an equation, the check is a little different. Not a whole lot though. So I'm going to check x equals 3. And once again, I haven't given myself a lot of room here. 2x plus 6 plus 7x equals 33. So I want to rewrite. Now I'm going to replace 2 times 3 plus 6 plus 7 times 3 equals 33. And this would be 6 plus 21 equals 33. And hopefully that all works out. That's 12 and 21. And that does work. If I add 2 and 1 and 1 and 2, I get 3 and 3. So that one worked out nicely. Alright, we'll have one that looks slightly different, but pretty much the same steps here. We have 8 minus 4x plus 4 plus 10x equals 30. It's a little bit bigger. And if we notice, we still have our x terms, and I want to make sure the negative comes with that 4x. And then over here, technically the positive is with the 10x. So I'm going to box those ones in. They match, so I wanted boxes for both. And then I have this plain old 8. Call it a constant, and this plain old positive 4. And notice I did not box those in. That way now I know the circles go together and the boxes go together. And that's an excellent way of showing your work when you're combining like terms. So let's combine the x's first. I have a negative 4x and a positive 10. So we got to get our integer brains working. It's really a 10 take away 4. So this is a 6x when you combine those. And a positive 8 and a positive 4, that's easy. You get 12. And the whole thing equals 30. I'm going to subtract my constant. And I get 6x equals 18. And now I divide by 6. And I get 3. And if you're wondering why the pen looks so weird, it's not my smartboard this time, it's my laptop, and I have a drawing tablet. So the lighter I write, the lighter it is, and the darker I write, the darker it is. It's kind of cool. So I'm going to do the check for this one. We have 8 minus 4x plus 4 plus 10x equals 30. Now I'm going to plug it in again. So 8 minus 4 times 3 plus 4 plus 10 times 3. Sometimes they're a bit of a pain. So this is the order of operations, right? I got to do multiplying first. So this is 8. And then this 4 times 3 is 12, so it's really minus 12. Plus 4. And this is really 10 times 3, so it's plus 30 equals 30. Well, if 30 equals 30, hopefully this whole chunk equals 0. And I think it does. 8 and 4. Well, I'll do this. 8 minus 12 is negative 4. Plus 4. That makes 0. So I think we're good here. So this is 30 equals 30. Squeeze that in there. So that's combining like terms. Last video I had you stop at 2 and that was it. This time I'm going to do something just a teeny bit different, and I'm going to add something for you. You are going to try this one on your own. So I'm not going to do this in the video. I'm going to look for it in the notes. So at the end of your Cornell notes, for your whole Cornell notes, I should see the 2 problems I did plus 1 more problem, this one, that done on your own. All right. Thank you.